Wonderful. Okay, thanks. So I start again. The work in Work Package 4 was dedicated to upscale innovative agroecological farming practices from the UNISECO case studies to the territorial level. In this case, the level of the European Union plus the UK. For the sake of simplicity, when I say European Union, I also include the UK. So we therefore modeled the land feasibility in terms of whether domestic demand can be covered from production from domestic agricultural land and the range of environmental and socio-economic benefits and impacts of 5 transformation pathways until 2050. In a stakeholder-driven process, we constructed and quantified 5 consistent types of storylines. These storylines mark paradigmatic potential future developments. The process and results of this exercise will be presented in the afternoon sessions. In another exercise, we modeled the land feasibility of a large number of conventional and agroecological scenarios in a multi-dimensional scenario framework. We assume no further deforestation and grassland change to cropland within the EU in 2050 in all agroecological scenarios. We here apply a highly aggregated perspective on the EU agri-food system because we are interested to see the systemic interrelations between the main compartments of the EU agri-food system. It's important to acknowledge that these scenarios are neither driven by desirability nor by likeliness, but only driven by the combination of different parameters in the agri-food system, which are derived from or inspired by the case studies. So for example, we have 2 distinct pathways for farming systems. Current livestock production patterns, conventional pathway marked in red, and an agroecological one where we better aligned crop and livestock production with feed production potentials, marked in green. The figure below shows the conceptual approach for the conventional pathway, a continuation of the current livestock production patterns as they are in the EU, with high feed imports and often not aligned with domestic agricultural land. For the agroecological pathway, we align livestock systems with feed production potentials at the NUTS2 level. This means that a higher share of livestock can be fed from domestic crop and grasslands. I will now go through all food system parameters we have included in our assessment. Each agroecological pathway, marked in green, comprises one specific or a bundle of agroecological practices for different agricultural and food system compartments. From top to bottom, these are ruminant livestock diets, current livestock diets with efficiency gains for the conventional pathway, and 2 agroecological pathways, a shift towards more cropland byproducts and roughage in feed, or purely grass-based livestock diets, but also assuming some efficiency gains. Monogastric diets and manure management, including more outdoor systems and an increase in biogas digester systems. Cropland yields, conventional yields, and comparatively lower agroecological yields. Cropland expansion, so no cropland expansion for all agroecological pathways, and additional bundles of practices, so a minimum of 7% hedgerows on cropland or undersowing in cereals and a shift towards foliar legumes. Grassland utilization, here we have a land sharing and a land sparing pathway. Allowances for the maximum sustainable grazing intensities, these are reduced in high natural value farmland in the agroecological pathways. And last but not least, dietary changes in the European Union and reduced food waste and losses. All combinations result in a total number of 420 scenarios, which we have assessed in a multi-dimensional scenario framework. So what are key results? Out of the 420 scenarios, 280 are land feasible. This means that an implementation of all of the agroecological practices is possible in the European Union in the year 2050. This is, however, only possible if current patterns of livestock production are not continued, and regions with large grassland feed potentials host a larger share of the EU ruminant production, and pig and poultry livestock systems are aligned with cropland production potentials. If current livestock production patterns are continued, domestic demand for food, feed, fuels, and fibers as well as certain export production, cannot be met on current cropland and grassland, facing limits of land available to produce these goods. Additionally, severe pressures from grazing intensities arise, and ecological thresholds on grassland will be exceeded in many regions. So we did not only assess the land feasibility, but also a range of environmental indicators for these 280 land feasible scenarios. All combinations of agroecological practices on the production side across the entire European Union deliver multiple environmental benefits. In order to compare these benefits and impacts of each agroecological bundle of practices on a range of environmental indicators, we show box plots which display the distribution and general trend of land feasible scenario results for selected indicators. Here, cropland extent and grassland extent in million hectares. The y-axis shows the spread of values for the selected indicator of all scenarios which include a specific bundle of practices. The x-axis shows these bundles of agroecological practices. So for example, 50% of scenarios which contain grass-based ruminant livestock, so this is panel 2, score around the median of 66 megahectares for utilized cropland, and the upper quartile of scenarios at 102 megahectares. All of these scenarios show a stronger reduction for grassland extent, while, for example, all scenarios which include ruminant diets that also include cropland byproducts score even lower and have a smaller inner quartile range. So we have included all agroecological bundles of practices in this figure, from left to right. Base year 2012, panel 1, ruminant livestock diets, panel 2 and 3, monogastric livestock diets and manure management, panel 4, agroecological cropland yields and specific bundles of practices, these are panels 5 and 6, grassland distributions, so land sharing and land sparing, panels 7, 8, and 8, a reduced maximum grazing intensity in high-value natural farmland, which is panel 9, and 2 different human diets, where we implemented sustainable and healthy diets in the EU, which are panels 10 and 11. Below you see further indicators. First, the land-based self-sufficiency, which is measured as domestic supply of crops and grass related to the demand for crops for humans and animals and grass for livestock. Second, grazing intensity, which is measured as the ratio of grazed biomass of the current net primary production. Third, biodiversity pressures. These are measured as the ratio of harvested biomass against the potential net primary production. And fourth, total greenhouse gas emissions shown in megatons of CO2 equivalents. So biodiversity pressures are relatively low in bundles 5 and 6, scenarios which include agroecological practices on cropland. But the positive effects on grazing intensity are less clear and show a large variation, as well as the impacts on land-based self-sufficiency. Positively spoken, the land-based self-sufficiency is not reduced by implementing agroecological practices on cropland, while, for example, the effect of dietary shifts for self-sufficiency are way more clear. So these are panels 10 and 11. Another result is, if you look at panels 7 and 8, the differences between scenarios which contain grassland sharing or grassland sparing pathways. In scenarios which incorporate a land sharing pathway, which is panel 7, grassland extent remains equal to the base year, but this allows that grazing intensities in all scenarios remain below the median values in all panels or in all other panels. Nevertheless, greenhouse gas emissions are higher than in a land sparing scenario, where livestock densities and highly productive grasslands are increased towards maximum sustainable thresholds. This allows to set grasslands free for or for afforestation and to create a net carbon sink. In the following few slides, I'm going to show subnational patterns of biodiversity pressures, shown as harvested biomass in percent of the potential net primary production based on the species energy theory. Underneath, you can see the heterogeneity of land use measured by the Shannon Diversity Index, and which is used as a proxy for the supportive capacity of agroecosystems to host biodiversity. The Shannon index is a composite indicator measured as the share of each proportion of land use, so for example, cereals or oil crops, in total land use, and the more equal these proportions are, the higher the Shannon index. You can see here the base year, which shows high biodiversity pressures in the northern parts of Central Europe and in the UK, and rather lower heterogeneity of land use in Central Europe, parts of France, and southern Poland. The animated GIF on the right side shows the changes of these indicators in 1 conventional and 4 agroecological scenarios. Clearly, the conventional scenario would exert massive biodiversity pressures in Central Europe and the UK in the year 2050. In the agroecological scenarios, we see decreasing biodiversity pressures and increasing heterogeneity of land use across most regions in the EU. Nevertheless, the overall range and spatial patterns vary among the agroecological scenarios, albeit at improved levels in comparison to the base year and the conventional scenario in the year 2050. Lastly, I would like to direct your attention towards total greenhouse gas emissions. We compare scenarios with the base year and the scenario with the current livestock production patterns in 2050, which are, however, land infeasible. But we would like to show them here as well to have as a kind of a conventional reference. Furthermore, we show box plots for agroecological scenarios, which include business as usual diets, conventional cropland management, or a full transformation towards agroecology in the EU. In all scenarios which contain elements of agroecology and a smaller EU food system, total greenhouse gas emissions decrease. Again, a smaller EU food system means less production due to a primary focus on meeting domestic demand and reduced export production. This would set large areas free, which are assumed to be afforested or left for vegetation regrowth. These are so-called natural climate solutions. However, the question arises whether these benefits come at the cost of agricultural jobs. And I can say that we found that the full switch towards agroecological food systems indeed decreases jobs in the livestock sector, but this loss is overcompensated by increasing labor requirements in the crop production sector. You can see the results in the right panel, which compares agricultural work unit requirements in the EU in the base year with an agroecological future in the year 2050. The results clearly show fundamental changes, but also a good opportunity for rural job provision. So a full implementation of agroecological practices in the EU is possible and provides environmental and socio-economic benefits, albeit some ifs need to be considered to avoid leakage effects. These are, firstly, only a redistribution of livestock production within the EU along feed production potentials enables land feasibility of agroecological scenarios. Second, yield gaps in agroecological farming exist, but are assumed to be lower than between conventional and organic farming. We allow for additional nitrogen fertilizer in agroecological farming if livestock manure and N fixation from legumes are insufficient. A third if are dietary changes towards healthy and sustainable diets and less food waste and losses. And the fourth if are reduced EU net exports, mostly cereals and to a lesser degree animal products. Some final take-home messages for all who are interested in the sustainable future of the EU agri-food system and beyond. Firstly, an agroecological transformation in the EU can be a no-regret option, but without changes in diets puts additional pressures on agriculture in the rest of the world and thus carries the risk of exporting environmental pressures. Secondly, particularly healthy low-meat diets and less food waste allow for several important measures. These are increasing self-sufficiency, nature-based climate solutions, such as afforestation on free crop and grassland, a general extensification of crop yields, and to secure agricultural reserves for the future if needed. This would also lead to a higher resilience of the EU agri-food system. And third, the biggest effects relate to changes that address total production and not on improving efficiencies. This is not yet a very prominent topic, but some first developments start to emerge. And finally, The socio-economic impacts of such a transformation are manifold and complex. More details on this in the territorial modeling afternoon session. Thanks for your attention. I'm aware that this was a lot of material to digest, thus I'm looking forward to your questions and to the session in the afternoon.
Thank you, Andreas. And I think you wanted your colleague Adrian to join us. So Adrian, you could just click the green button. So we have two questions that I think we have time for, and I'm going to just kind of pose them both. And you can choose how and you want to kind of respond. So the first is just to say a little bit more about what is included. Hello, Adrian. Thank you for joining us. So what is included besides agriculture? So thinking about climate change, population change, migration. So other things beyond agriculture is one question. And then the other is whether you could say a little bit more about what is meant by the biodiversity harvest.
Mm-hmm. Thanks, Kate.
Yeah. Mm-hmm.
Thanks for these great questions. So basically, we included factors derived from the agri-food system, and this includes agricultural practices from the plot level to the higher spatial level, but also factors from the demand side. So not only production side measures, but also demand side measures. And these are diet and food waste and losses. And we see that this full integrated perspective is essential to be able to correctly assess the likely impact of such a transformation, because the total size of the food system is decisive. This is what I also referred to in my last point when I said, well, a transformation to agroecology can a no regret option, but only this if the total size of the food system is reduced. We also involved population changes. These were derived from the most recent FAO outlook. Climate change is kind of reflected because we also derived our yield forecasts from the FAO. So this is included, but it's not directly included. So we do not model direct effects from climate change. So this was the first question. And the second question from Alexander Wetzel was, that is not sure to understand what is meant with biodiversity harvest. We here refer to biomass harvest, and we use biomass harvest as a proxy indicator for biodiversity pressures. So this is basically the relation of harvested biomass together on cropland and on grassland in relation to the potential net primary production. And there we see, we can then compare the shares to the status quo, and then we see whether there are more or higher pressures or less pressures. Nevertheless, I have to assume that this is a composite indicator. It's a proxy indicator. Of course, we could not assess the direct biodiversity effects on the spatial or on the plot level. This was beyond the scope of the territorial modeling session. But I guess there are some more information from Work Package 3 from the case studies.
Great, thank you, Andreas. I think we have time for maybe one more. There's the one that's come in from Esther. So this is questioning about the role of legumes, increased production of legumes in the EU. So to what extent that role might have been taken into account in terms of considering the transition?
We implemented several kind of what we refer to bundles of agroecological practices. And one bundle of practices was firstly undersowing in cereals with clover and maize. And there we see kind of synergistic effect, because the first effect is the provision with nitrogen, or the nitrogen fixation effect. And the second effect is, if not everything then is blasted into soils, but a part of it is also used to feed ruminant livestock, then we also have a positive effect on grasslands or on grazing intensity. So from this perspective, I can say, well, legumes can contribute, and they are an important factor for agroecological systems, but maybe Adrian, you want to add here as well.
Yes, they are definitely central in the agroecological system, and maybe it's sort of both way. An increased focus on agroecology will naturally bring in more legume production into the system, because it's on the level of closing nutrient cycles, not using less mineral fertilizers from outside and so on. So this is definitely a key aspect to look at, and also complementing this one aspect of the reduced size of the food system, which is the reduced consumption of, oops.
We can hear you, Adrian. We can hear you well.
Yeah, no, there was a strange tone on my side, sorry, a strange noise. The reduction of consumption of animal source food, which needs a replacement on the protein level, for example, which then is also provided by legumes again. So this fits all very well together on a production and on a consumption side.
Great.
And maybe to add one more sentence, since the production patterns in the EU are driven by domestic demand, then also like this increasing demand in less meat diets, the increasing demand for, as you write, Susanna, lentils, lupins, faba beans is also reflected in the production patterns. And clearly soya is as well a legume, we know. But since we also kind of changed the diets or the livestock diets, we have a lower share of primary cropland products in the agroecological scenarios.
That's great. I'm going to thank you guys very much. I think in the interest of time, we're going to move to the next speakers. But as you note, Andreas, there's a session this afternoon running twice. So if people really want to get into the details, they can attend both of those sessions. But I'm sure that you will get into further detail there. Thank you very much, Andreas, and thank you, Adrian, for joining us for the question session.